Welcome to No More Bad Dates, Best Practices for Working with Dates and Times in SQL Server. I am Kendra Little. I am a founder of Brent, Ozar, PLF. Some of my co-founders are here with us as well, Jeremiah Peshka and Brent Ozar, who will heckle me from the front row. Feel free to heckle them back, and I'll repeat your comments so that we can all enjoy them. I'm a full-time database consultant, and I love to write about SQL Server and also draw about SQL Server. So what you see on the screen here, there's a couple of posters that I've created. This one is on isolation levels in SQL Server. There's one on table partitioning in SQL Server. And I have a new one that is on dates and times in SQL Server, which I'll be handing out at the end of the presentation today. So if you're interested in that, you will get the first 200 people will get a chance. So there's a benefit for sitting closer to the front today that wasn't published. All of the drawings that you see in the presentation today, I drew myself as well. The one picture I didn't draw in this presentation is right here. This is the official Microsoft Certified Master in SQL Server slide. And I love this slide because I don't want to say that Microsoft Certified Masters aren't handsome people. However, none of us are as fit as this man. But I am a Microsoft Certified Master in SQL Server, which means that I can break a lot of stuff in SQL Server and then fix it. And I love to learn about SQL Server is essentially what this means. If you're interested in the Certified Master program, if you want to know what's the road like to get there, how can you move along it, come talk to me after the presentation, and I can help figure out where you are, how to get you along that direction, and connect you with other resources as well. What we're talking about today. First, I want to help you understand things about date and time data types that may surprise you, things you may not know about the types and how to choose which one you'd like to use. Also like to talk a little bit about languages. It turns out language is very important when it comes to dates and times, which isn't really obvious at first. Talk a little bit about math with dates and times, when we're aggregating, when we're rounding, when we're reporting and grouping on dates and times. What are some of the pitfalls we can hit? What are the ways we can do this the most efficiently? Also, in general, where are the performance gotchas that we're likely to hit when we use dates and times in our schema? Where have people had very common problems before, and how can you avoid these problems? And how do you know when a change is worth it? I'm going to talk a lot about different data types. And how do you know, looking at your existing schema, is it worth it to me to change to my types here? What are the benefits of this? What are the risks of it? And should I change my practices when I'm creating new databases? Should I be using different types than I'm using now? We'll talk about 5 best practices and cover this ground. Unofficially, I have 3 goals, though. Really what I want to do in this presentation is talk about new possibilities and help you start thinking about new possibilities. What are the different ways that I can code and create? What are the changes I can make in my schemas and my queries and my reports? Because to me, one of the best things about a conference like this is learning from other people's experiences and the information they give you that you didn't already know. What are the changes and possibilities that I might be able to do? Also, I want to sort of convey how lean schema, how a seemingly small change in a schema and making that schema leaner can help make a difference and can make your application scale better. So a simple thing like a difference between 2 types, what can that do for you in the long term? And finally, I want to give you exposure to a few things that may help you out in the middle of the night when you're up late and something's performing really poorly, or at 4:45 in the afternoon when you're like, why isn't this query done? Why is the application slow? Why is the DBA making growling noises next door? This can help you finish up your work and get going. This is our hero today. This is our assistant. This is Chris Magoo. Chris Magoo is a database developer with 3 years of experience primarily developing .NET. And Chris Magoo works with a team of other developers and has become the sort of de facto database expert. People have started going to Chris and realizing that he likes SQL Server, and they ask him, how should we write this query to be better? Why is this slow? How can we make this faster? When we're designing new tables, how should the tables be structured? So Chris has sort of fallen into this, hasn't had a lot of formal training, and is starting to realize that things are a little more complicated than he thought. So here's my question to you. What do you call yourself? So how many of you primarily write application code on a daily basis? It might be Transat SQL. It might be .NET code. OK, good amount. How many of you are primarily database administrators? You may write T-SQL, but OK, got a bunch of you. Anybody in business intelligence? So you write reports? Okay, so I've got a good distribution today. And I think what I have should cover a lot of ground and be useful to a lot of you. I actually tried to design this presentation to talk to people from different sides of this. So you have feedback on how it relates to your particular discipline. I would love for you to give me that feedback, and I'm very interested to hear that. The first of the 5 best practices we're going to go through is knowing your types. What are the options we have when it comes to dates and times? So someone comes to Chris on his team and he says, we're creating this new database. Tell me how the schema looks. Please review this. So, it's okay. There's a lot of things to look at. Where do you start? The general principle I like to start with dates and times is to ask, how specific do I need to be? So this isn't just how specific do I need to be about how complicated the schema is or not. But it's actually, there's 2 sides to this. How specific is the data that we are getting into the database? How accurate is it? Is the data that we're getting, does it have 7 decimal points of a second accuracy? That's some special data, because most data doesn't. Is it only accurate to 1/10 of a second? Is it only accurate to the minute? So understanding the data that's coming in, where it's coming in from, the accuracy of that is one thing that you want to know. You also want to know, conversely, how accurate do you need it to be? How are you going to use this data? Do you really need 7 decimal points of a second of precision? Is that actually meaningful in your application? Or would no partial seconds be okay? Would data to the minute be okay? Would just the date be okay? For different applications, you'll have different answers. So you want to find out these 2 things and find out how they match up to identify whether the schema that you're looking at fits both of these needs. Now, of course, if the data that's coming in is not very accurate and it needs to be very accurate, you need to go back to the business users and the sources of the data, and that has to get worked out. So that may buy you some time there. But usually you really need to figure out, how much do I need to store? Here's our old friend date time. What we're doing here is we're taking a string and we're casting it as a date time value. I'd like to draw your attention to the platform Chris is standing on. This is an 8-byte platform. So for the date time type, for each row that we're recording, we're going to get 8 bytes of data, not counting all the other stuff in the record, just for that date time column. The other thing I'd like you to notice is the value that we're casting has .555. Now, I could call that milliseconds, but really what this is fractional seconds, because notice what actually gets stored here is .557. One thing that's sort of weird about the date time data type is that it's lumpy. It is a lumpy type. It will store things at this fractional second level, which we would normally call a millisecond. It will store things as a 0, a 3, or a 7. And it will sometimes round things up, sometimes round things down, but you're getting only things that are so accurate in there if you're using date time. And this is just related to the way that it stores the data and how accurate it can be. So this is one of the things we don't notice very often, but it's actually kind of weird. It's a little bit of a lumpy type. We also have small date time. Small date time is, like date time, been with us for a while. It goes back to the Sybase days. And the first thing that you may notice is that the platform Chris is standing on has shrunk dramatically. We've gone from 8 bytes to 4 bytes because small date time really is small. The name is meaningful. It is small. Small date time is only accurate to the minute. And if you notice here, look at the value we're putting in here, and then look at the value that we get. We've put in a value that is 30 seconds past. We get a value, it rounds up to the next minute. This is fully documented for small date time. It's supposed to work like this. But it isn't how we think of dates and times. If you have a user who's using this data and writing a query against the data, right, and they're writing a report for all of the sales in the last half hour, and they run their aggregate number and get 10, and then they look at the detail, they may see more, if any, happened in the last 30 seconds of that hour, and that may not make much sense to them. So whenever you're looking at this whole granular data versus the aggregate data, the way that small date time rounds makes me a little uncomfortable. Because even if you know about this and you handle this in your code, eventually this stuff gets put in a reporting system where your business users can query it, and then they become very confused. So small date time is great because it is small, but it has this sort of weird behavior and some pitfalls. Next we have date. Date is one of the newer types that was introduced in SQL Server 2008. Date is kind of, a lot of people when this first came out were excited about this. This is great because check out the platform because it's standing on. It is only 3 bytes. It is nice and small and tiny. Date is handy. It is simple. And all of that work that we used to have to do with chopping off the time from things, you can cast things as date, get rid of the time. It's really, really useful. Date does not round up. Check out that I put a value at the very, very end of the day. I put lots. I put 8 nines on here. I tried to get this thing to round up. It did not round up. So that's a little different between our other types. Date time will round up, and our newer types will round up, but date will not round up. So you just sort of have to know that and take account of that if you're really going to get into the nitty-gritty of things. Things that happen at the very end of the day will be counted as on the same day if you cast it as date. Yes, I think it does make sense, but the fact that other types behave a little differently can confuse people. So yes, to me that also makes sense. Here is time. So we have date. We have a time data type. The really cool thing about time, notice that there's 2 different colors of blocks. Here we have red blocks and green blocks, and the green blocks are optional because time has a configurable precision. I have put here that I want time with precision 1, which means I'm getting 1/10 of a second. If I were to put time 0, I would get no tenths of a second. So my storage that I use will vary based on the precision that I say I require. And I think this is fantastic because essentially we now have the ability to store as much data as we want and control how much space do we need to use, how accurate do we want to be with this type. It's really, really useful. So we aren't getting, because I specified 1, I'm going to get 4 bytes for this one, and I'm not going to store all of that other stuff. Now we have date time 2. So how many people are using date time 2 currently? I've got some people. Okay, so a lot of times when I give this session, I get nobody. So how many people have heard of date time 2 and know about it? Okay, so actually a good amount of you actually know about this, and a lot of times people haven't even heard about this. Date time 2 is just like, similar to what we just talked about with time. It has a configurable precision. So here I have said I want date time 2 0. I don't want fractional seconds. This means I'm only going to store 6 bytes of data. Date time 2, like date time, this is similar to date time, it will also round up. I'm putting in a value at the very, very end of the day, and it is rounding up to the next day. This part isn't different from date time. Even though date time is lumpy, it still rounds up to the next day if you give it a high enough value. Yes? Thank you. So Lewis asked, the question is, what is the -7 here at the end of the string we're passing in? This is a time zone, an indication of what time zone we want to store the data in. And notice that this doesn't change the time that's stored here by date time 2. You can give date time to a string that includes time zone information, and it just doesn't care about it, but it will not throw an error. So know that if you have time zone information and you're feeding it in, you can actually feed that into a date time 2, and it'll just ignore it. We have one case where it won't ignore it, and that is for date time offset. So we're taking the same value here and we're passing it into date time offset, which takes a configurable precision just like date time. Here I'm giving it 0, and in this case it actually records the time zone information. This is the only data type that is time zone aware, and where you can make, if you need that in your applications, you can use this. Note that its storage size is 8 to 10 bytes because we have to use some extra space to store that time zone information. It will default to UTC, by the way. Here is a summary of all of our types. Don't worry too much about reading this whole chart because this will be with the handout I give you at the end. I'd like to draw your attention to 2 things. One is the diminutive size of the date. Look how small that 3 bytes is in this sea of larger bytes. That's really fantastic. And the other thing is this. Date time and small date time are technically not recommended for new development. If you look at the pages for these types in Books Online, it has a warning that says not recommended for new development. This means that the SQL Server team doesn't want you, when you're creating new applications and new databases, they don't want you to use these types. They want you to use date time 2 and date and time. And the reason is those new types they conform to international standards better. They conform to standards for relational databases better. They're what they would like us to go out and use. And they also let us say exactly, how much storage we want to use, how precise we want to be. They have more features. But even though it says this in Books Online and it's pretty strong about it, I don't find a lot of people using the new types when they create a new database. We're used to just using the types that we know. So there are reasons that we may want to switch, and these are are a lot of what we'll talk about today. There's even reasons more than the size on disk. So recapping best practice number 1, don't expect everybody in your team to be reading books online every time they're designing a table or adding a column to a table. We don't all refer, I mean, there's a ton of pages in books online just on dates and times. And that is a constantly shifting source of information. Instead, have a cheat sheet available. Have documented practices for these are the types that we're using in these applications. These are the types that we use in these applications. Here's the level of precision that we need. And just share that with your team. Share your preferred uses of types and just have that documented so that people don't always have to keep looking things up. Second thing we'll talk about today of our 5 best practice is understanding the impact of languages on dates and times. And here is where our demo starts. We have 2 demos today. We are using a database called Date Time Testing. This is just a Scratch database that I have created and created some objects in for us to use. And here we're mostly going to be looking at system tables in SQL Server. So we can see the languages in SQL Server in the sys.syslanguages table or view. This is a system view. And when you look at it, you can see that we have 34 languages that are available to us. The first one starts with an ID of 0, and the first one is US English. And the table kind of gives away, or the view kind of gives away, that this is about dates and times by mentioning things like date format, date first, the months involved. So we already know that this has something to do with how we use dates. We set what language we're using in 3 different places in SQL Server. We have a system configuration for the default language that the instance is using. So you may be writing code that is running on a server where this is a different value than anything you have tested. This is one of the things to know. This is a view of what we set in spconfigure, this sysconfigurations view. So here we're saying our particular instance has the value of 0 in use, and that's its setting. That is US English. We also set the language on logins. When you create a login, it will default to the server setting, but you can change that on individual logins as well. So our certificates don't have these, but our actual users all have these settings. So I have here US English for a lot of my logins, but then I have a test login that has the default language of German. So whenever anything is using that login, it's going to use that language. So even if you change the setting on a server, say the server was created with the language setting you didn't want to use, and then you go ahead and change it, those logins may still have another value set. So whenever things are running under those logins, they're going to use whatever they have set. The third place of the 3 is within a session. We can set what language we want to use in our session. So right now, I can look at system exec sessions and say, of all of the sessions running on the server, what language are they using? Right now, I have 3 sessions all running under my account. These are just the user processes that are using English. If I change my setting to Arabic and then look again, I will see that it updates automatically, and it can see that my setting is now Arabic. So you can quickly see by looking at this what is running for different sessions on your server. You can also, for your own session, run dbcc user options to see all your settings. And check out here, we have language setting and our date format and date first. This actually gets even more complicated because you can even change your date format and date first settings within your session as you want, right? Should you do that? I don't advocate that you change a lot of these settings all the time. There is actually an easier way rather than changing all your code to make sure that you're always using a language setting. I'm going to go back to English. And here's really why we care. I'll run a little demo code where I create a table. I'm going to set my language to English and insert 2 values, and then set the language to British and insert the exact same values, and then select them out. What happens for the exact same values that went in, I got October 4th for English. But for British, for that second value, where the format had 10/4/2011, I got a different date stored in the server because it interpreted it differently. Because in Europe, you specify the month and the day in a different order, and that's SQL Server's trying to say, I'm going to interpret this according to how your custom is to specify it. So this is why this really matters to you. If you don't take account of what language your code is being run under, and you're concatenating strings together, you're sending out scripts to fix some data, you can end up with data stored that isn't correct, and that's no fun. There is a fairly easy best practice that you can do to take care of this, and that is you can use a language-neutral format for your date. So I'm going to run a cursor here, and I do take a particular pleasure in running a cursor in a SQL Pass demo. I'll highlight this and then go back to the meat of the code. What I have done here is I'm just rolling through all of the languages, and I'm setting the language to be that language using set language, and then you can actually use a variable for this, which is very handy. So you don't have to use dynamic SQL for this test at all. And then inside that, using that language format, I'm inserting into a temp table the same values. One value is in a language neutral format. This value here that has the T in the middle is language neutral. And then I'm using a language specific format, secondly, for my test. And you can see in the results of my table, for the language neutral format, I do always get the same value stored. I get expected result. For the language specific format, it varies by language. The best practice here is always use a language neutral format. It simplifies things for you. You don't have to worry about the language setting. It takes a lot of the worries here out of the way. And here is that language neutral format. It's ISO 8601. If you search books online for ISO 8601, it'll tell you all about it being language neutral and easy to use. You can even just specify the date here without the time. It's best practice to actually use that T there between them when you're specifying both. There are some other language neutral formats you can use too. You actually do have a choice. You can pick the one that's right for your team and document it, but just as long as you're using a neutral format, things will be easier. Nobody likes it when data is wrong. There's one other interesting language that crops up from time to time that I find really interesting, and that has to do with the isDate function. The isDate function is not deterministic. This is an interesting sort of concept, and let me show you a little bit about what this means. Here's an example of some code to create a table. This table has a column named SumValue, which is a variable character length column, and it has a computed column that I'm trying to create that says if SumValue contains a date, give me the date value, convert it to a date time value here. Otherwise, don't put anything in here. And then it tries to persist it. The reason that people want to do this is they have data coming in that they need to clean. They need to take this data and figure out, is this actually a valid date? Is it a number? So they need to bring it into a table and then run a bunch of queries in it to clean it up and make sure it's really valid. The other thing, sometimes people like to use this in OLTP schema design where they have a table that contains some stuff and then they create columns for if it's a number, if it's a date, if it's something else. I am not necessarily fully on board with that as a schema design, but people who want to do it are often frustrated by this issue, and it is a little frustrating. Here's what happens if I try to run this code. I get an error. I get the error that says my computed column can't be created. It cannot be persisted because the column is non-deterministic. This is because of the isDate function. If you were to do this and not persist it, it would work. Each time it reads from the table, it could actually figure out that value. I want to persist it, however. I want to write that. Persisting means I am having the table, the computed column, actually write that data to the page at the time that the data is inserted or updated or written. And that means I can index it, right? So if I have a lot of data I need to clean, I really want to persist it in index instead of recomputing it every time I read that table. So it says because isDate isn't deterministic, this won't work. This is because I haven't given isDate any information about how it's supposed to figure out if it's a date. What language is it supposed to use? Is it supposed to use the server language, the login language of whoever created the table? Is it supposed to try to figure out from different users at runtime? That's kind of wacky, right? So I've tried different ways to get this to work because the documentation in Books Online sort of makes it seem like this should work. So even when you wrap isDate around an isConvert that takes a style, a language neutral style of 20, it doesn't work. You get the same error. However, in SQL 2012, otherwise known as SQL Tunali, we have a new function that is really cool. It's both for this issue and for other issues. It's try-convert. And try-convert does just that. It tries to convert a value, and you can give it a style. So here, I have tried to convert the value hullabaloo into a date time 2 with style 20, and it gives me a null because it can't convert it to that. It doesn't give me an error. This is the really cool part. I don't get an error. I just get a null. For the actual date value, it works for that. And because I can give it information about what style to use when it tries to convert this, that is enough for it to be deterministic. Because now I can actually create and persist my column if I want. So I can do this successfully. I have now created date values as a computed persisted column. I can insert values into it, a lot of different values here, badgers, zombies, dates. I can create my magic unicorn index on it successfully, and I can run a query against it. And let me put on an execution plan real fast. I can run a query against it and actually use my index that I created. And all you really need to see here is that it's seeking from my magic unicorn persisted index here, and it's actually using it. So that's very cool. Try convert is useful not only for persisting columns, but also for checking date values. This is one of my favorite new pieces of T-SQL functionality in SQL Server 2012. I think it's going to simplify a lot of code where you're converting values and you have to do a lot of error checking. So that'll make our world a lot simpler in writing pieces of code. And I have a little bit of a window issue here. Let me clean that up. Oh. You can see some of my notes from previous sessions. I like to take notes. Okay, here we go. Best practice is what we've covered about languages. The big thing with languages, use the language neutral format that we have here. Save you a lot of headaches and trouble. And understand, try out try convert when you get there. Use it testing your code. And understand what kinds of computed columns you can persist in and how that relates to the language issue. Math is hard. This is our third of 5 best practices, is to do your math right. We use math with dates and times when we're aggregating. We want to often say, how many sales did we have in the last month? How many transactions did we do in the last, 5-minute segments for the last hour? These are very common things that we do with dates and times. We don't have any built-in functions for rounding. There is no function that you have that says, take this date and round it to a month. But we do have an awful lot of functions with date and time. We have all of these things, right? Some of them return dates, some of them do things with date, but none of them just specifically round the dates for us. I do want to remind you, you need to remember when you're working with these things, date is not going to round up, and small date time rounds at the 30 seconds. So you've got to kind of handle those two things at your code. I worked for a little bit to just figure out, I had a bunch of data that I actually needed to aggregate to the minute level. And I wanted to know, okay, what function is the fastest for this? What should I use with all of these millions of rows of data, and how should I code this to actually be able to round to the minute level fastest? And along the way, I learned a lot about why certain things were fast and certain things weren't. So I compared a bunch of different methods, and I primarily compared them by using set statistics time on before I ran a large query, and then using that, it outputs the amount of CPU time that was used by that query. It'll print a message for you. So I used that CPU time on the same system. I did multiple runs of each one to compare them against each other. My first one here is called, I call it date partorama. And it's the most intuitive one. It's where you take a date and you say date part year plus concatenate it with a dash, and then date part month, and then concatenate it with date part day. And there's lots of typing in here. So you essentially do date parts for everything you want, and then concatenate it with like zeros. And then you convert it or cast it back to a date time value, right? This is a pain to write. Nobody likes to write this, but it's kind of the most, it's the one that we usually come to first if we're trying to figure out how to do this on our own. It took 23,000 seconds of CPU time, which is kind of a lot. My second attempt was much faster. I call this one the subtract the fluff method. What I did first is I converted to a date time 20 to get rid of all those partial seconds so I didn't even have to worry about them. And then I was just going to the minute level, so I just needed to figure out how many seconds were on each value and subtract the seconds, just the number of seconds, to get to the minute. This was considerably faster, right? We went down to 7,265 CPU seconds. And if you look at this, the reason it's faster is we're not going into a string at all. We're just doing math on this. These are stored as integer-based data, so using a math-based function on these is always going to be faster. That is proved by this method. This is one of the ones that I've seen used most commonly at clients and in code around. And it's conceptually simple. That's why we do this. What you do is you take the value, you convert it to a character value with a given style, in this case 121. And we know in this case if we go to style 121 and we only keep it 16 characters, right, it will chop off the parts of the date we don't want. So we go into character, chop off what we don't want, and then we go back to date time 2. This turns out there's something about this. It becomes really easy to type and remember for me. But this one was twice as expensive as even the subtract the fluff method. So because it's going into the string, it's more CPU intensive. The fourth and final one here, who is my winner, is actually the date diff from the beginning of time method. And if you look at its time, it's not actually that much faster than the subtraction method. So the message here is figure out what rounding function, figure out how generally you need to round. Figure out what rounding function works for you, is easy for your team to remember and people like, and standardize on that. Make sure it's math-based is all. Here's the detail on the one that was the fastest. Essentially, you figure out with date diff, how many minutes has it been since 0, or the beginning of time, and you use date diff, and then you use date add. So you're like subtracting and adding the minutes from the beginning of time. And that's super smoking fast. We do have one function. I said there's no functions that round. We have one function that's coming to us that rounds, and this is in SQL Server 2012. They're giving us a function called EOMonth. And this is kind of cool. I mean, we can say for this date value, tell me the date of the end of the month, and we can give it an integer, in this case -1. So I'm saying give me the end of the month for last month, right? So that's pretty cool. But we don't have a beginning of the month, right? And when we aggregate data, a lot of times we want to know the beginning of the month. So we're still going to have to do something a little complicated to get beginning of the month, but we have a simpler way for end of month, so we're still kind of unsatisfied, I think. So EOMonth, nothing against it. You may start to use it. It may be useful, but I don't expect EOMonth to revolutionize your world. In general, what we want to do is just have that concept of when we're doing rounding functions, pick the math-based ones, not the ones that convert to string and back. Understand where small date time may lead to aggregate results that don't match up with your detail exactly and how that may confuse your users. So if you do use a lot of small date time, share documentation about why things work the way they do. And understand who doesn't round up, which is date. Performance gotchas. Performance gotchas are definitely my favorite part of this talk. When I did 24 hours of past, this slide had a kitten beneath the piano, and I did get some negative feedback on killing the kitten. So in this case, I have a developer, right, beneath the falling piano. I hope that's less offensive than a kitten. Scalar functions are dangerous. And in general, functions in SQL Server are dangerous is the message I want to get across. They are very handy for using repeatable code. I'm not against them, but we have to be careful when we use them. We're going to do a little more demo here. Woohoo! All right, things are set up properly on the screen. For my sample here, I'm using Contoso Retail Data Warehouse. Any of you guys familiar with Contoso Retail DW? Anybody use this? Got a couple people. So if you search online for Contoso Retail DW in Microsoft, this is actually a sample database provided by Microsoft. So similar to AdventureWorks, they provide this. And it's a data warehousing sample database that has a star schema and fact tables and dimension tables. So for some demos, I just find, and it has more rows and tables, less sort of OLTP stuff than AdventureWorks does. So it makes sense to me to do some testing on it and do demos on it, and I think it's a really useful database. I have a fact table called Fact Online Sales, and right now I have a clustered index on that. That came with Contoso Retail DW, and I have added this non-clustered index here on date key, and I'll scroll over. This is on date key, and it actually doesn't have any includes at all, which this wouldn't show us if we did have includes, but I can tell you it does not have includes. The reason that we have this index is because we run this query often. Frequently, we want to know how many sales we had in a given year. So we do this, and we say, select count star from the table where the year of the date key equals 2009. This is, what most of our users would do too, right? Most of our business users would figure out this is what they want to do. I'm going to turn on my actual execution plan and run this again. So I'm getting back that I have 5 million rows. And if I check out my execution plan here, I can see that I am using my non-clustered index here, which we can actually see because it starts with IX here. And if I scroll in a little bit at the very bottom here, you can see that it's using my non-clustered index. I'm using parallelism, though, and this is a fairly expensive query. If you look at my estimated subtree cost, it's 32 there. So we're doing an awful lot of work for looking at a non-clustered index and just counting. Now, I have set statistics IO on and set statistics time on, so I can see that I'm doing the number of logical reads I'm doing right now is 28,000, right? So I'm doing a lot of logical reads. And my CPU, 2,406 milliseconds. Let's try a different approach and see if we can make this a little faster. So I'm going to take this query in a different way, and I'm going to create two variables, one for the beginning of the year and one for the end of the year. These are even date variables, and my column is not a date. My column is a date time, right? So I'm creating date variables, and I'm saying where date key is between these two. I'm going to execute both of these queries. There's the first and the second. So good news, they return the same results. We like that, right? When we compare our execution plans, note how much cheaper our second one is. Considerably cheaper, and it looks really, really different. So instead of doing an index scan on our non-clustered index, let me make this a little larger. What we're doing is we're figuring out our variables over here in this part of the plan, and then our nested loop operator is actually making a targeted duck in to do less reads. In fact, when I compare our logical reads, so here's our first run. What I like partly about this is that I can actually delete, on the Messages tab, you can actually delete stuff to make your output a little more readable here. Let me do a little return so we can see our logic. Here's our first logical reads for our first query of 28,000. And now for our second query, we did half that. We only did 11,000, right? So we did many fewer reads by using this second query, and our CPU time was also cut in half. This has to do with that function. SQL Server is not exceptionally smart when it comes to putting a year function around something and having to then use an index. And there's even a suggestion filed for this on Connect for this particular issue with year functions that Simon Sabin, who's also speaking at the conference, put in, where he says, you know, SQL Server should be a little smarter around this. We shouldn't have to use workarounds for this. So you can actually, there's a link to the resources page. You can actually go vote for that suggestion if you want to on Connect and say, you know what, this should be smarter about this, because users, I mean, even if we all learn the workarounds for this, our users who are writing reports aren't going to all necessarily know this, right? So can anyone think of another option except for these two things? So that, you know, putting a scalar function around something or specifying the dates. Is there anything common that you use that means that you don't have to do either of these two things? Any guesses? Okay, the third option is the calendar table, or a dimension table that is specific to dates. Contoso Retail DW conveniently comes with one of those tables. So here's what this looks like. This is a dimension table that has a key with a date, and it has a bunch of other columns on it. So we can join to this table on the date key and then group by any of these other columns so that we can easily see things that are in a given calendar week or a given quarter or something like that. This can help solve that problem with the year too. A lot of times when we have date calendar tables, they're extremely convenient to join to, and a lot of times we have associated functions with them as well. If we run this query that joins to our calendar table and gets that date, we actually get something, in this case, that's a little bit in the middle. It's a lot better than the first query, but it still costs enough that it uses parallelism. It's a slightly different plan than that second one. So in our case, it's not the most efficient query, but if our users were running it, we would actually probably be a lot more satisfied with it because it uses less CPU and actually does fewer reads than the first one too. So calendar tables can be a great option. Just know if you build date functions to go with your calendar tables, you need to be really careful looking at those and make sure that people are wrapping those functions around a date value, that it's able to use indexes efficiently, and that it's not having to go to each row and do a computation on that row as it reads the data in, because that's what happens with scalar functions. It has to evaluate each row frequently and do a calculation there, and that isn't cheap. So scalar functions, they will get you. The second perf issue I want to talk about is called the ascending date column problem. And this is something that, in me personally, this is really when I started learning about this problem, was when I started learning about execution plans. I had some queries that what they did is they went and they looked in another database and they said, can you give everything that's come in since I last checked? You know, I've pulled data over since yesterday at noon. Can you give me everything since yesterday at noon? And they would run frequently. So, you know, sometimes it's everything in the last 5 minutes. Sometimes it's everything in the last hour. These worked fine for a long time, but as our data started getting larger and larger, things started periodically getting slower and slower. Here is how we can work with those. I'm going back to my date-time testing database. I'm going to turn off my execution plans briefly. And I have created a table that has 1 million rows for this demo. It's the transaction table. And looking at just the last 10 rows, you can see I have up to transaction ID 1 million. Each row has a transaction date on it, and each row, there's 1 row per minute going backwards. So the most frequent row is from 10:05 a.m. this morning, and then all of the data is older than that. And units sold I have made to be 1 or 0 for all these million rows. So the narrow table, and it has 1 million rows. And you know, 1 million rows these days isn't that much, right? 1 million rows used to be a lot of rows. It's not so much anymore. I'm going to create a non-clustered index on the transaction date because I want to know a lot about our transaction date. When we're doing this, show me all the records in the last 5 minutes, typically we have an index on our transaction date, right? So I have a nice shiny index, no includes. I'm just saying put my index on transaction date. You can take a look at our indexes and you'll see that I only have my clustered index and then the index I just created. That's all we've got there. Very simple. So SQL Server uses something called statistics to estimate how much data it's going to get back from a given query. And we have statistics for our new index. So when we created that index, SQL Server actually, as it was building that new structure, it took advantage of looking at the whole structure while it was building it to also figure out in the meanwhile, if I was going to query this, what's the data like in there? So it has a sense of all our dates and times that are in our non-clustered index there. We have 1 million rows, and SQL Server will try to manage its understanding of statistics on that index based on the number of rows in that index. So its formula that it uses is it will use when 20% plus 500 of data in that, of rows change in that table, either by being inserted or updated, it'll go and estimate the statistics for that again. This is based on a database setting called auto update statistics. It will do that when the table is queried. So I can change, in this case, well, let's look at how many rows can I change before my statistics update on my date index. I can change 200,500 rows before my stats change. It's kind of a lot. And if I had 10 million rows, it would be even more, right? So as our tables get larger and larger, since we're going at a 20% rate, 20% plus 500 for statistics update, lots of stuff can change in that table before SQL Server stops and looks and reassesses what the distribution of data is and the selectivity of data. Here's a little glimpse into what the statistics are like for our date index. And let's see if I can drag this up here. Here we go. This is a fairly simple example, and I really like statistics. They can get a little more complicated than this, but I'll give you some tips on if you haven't looked at stats before. Always look at rows and rows sampled here. Rows is how many rows were there when it looked at it, so in our case 1 million. Rows samples is how many it considered when creating the statistic. In our case, since these are equal, we know that this was when I created or rebuilt the index, or if you updated statistics with full scan, it would do the same thing. So I know I have as good a stats as I'm going to get on this thing. I also know when they were updated, and it was at 10:56 a.m. And I have information here in the bottom about the distribution of data. What this is telling me is that the range high key, the highest date that it knows about in this table right now, is at 10:05 a.m. And it has a whole lot of rows in there, just about 1 million, and there's a lot of uniqueness in there. What you really, it's the really easy thing to remember, especially if you aren't looking at these, is range high key can help you figure out what the most recent thing it knows about is. That's our fresh perfect stats from when we built that index. So now let's insert 200,499 rows. So just one row shy from what I believe will trigger our stats update. And I'm just inserting, I'm actually pulling this from the transactions table, but you'll see I'm not actually pulling any data from there. I'm just using that as sort of a numbers table as a quick way to get a lot of rows without doing a loop. So I'm putting in values for tomorrow. So these stand out really well, right? So my rows that were in there before were from this morning and prior. And now I have put in 200,499 rows with the date of tomorrow, and 3 is the number of units sold. We can see real fast that our statistics haven't changed, right? Our updated data is the same. Our rows and rows sampled is the same. I'm going to turn on my execution plan and turn my statistics IO and statistics time-o so that it'll tell me about reads and writes. And I'll run this test query. Here's a query that just wants to know, give me the units sold and the number sold for each of those units. Here's the important part, where the transaction date is greater than now. So this is only going to pick up the rows I just inserted, right? The 200,499. That didn't take long, right? That only took a second. That can't be so bad, can it? If I check out my execution plan, things are kind of complicated, though. It doesn't look horribly bad at first. I have this little warning sign here. That's always a bad sign. We'll take a look at that in a sec. What I'd really like to draw your attention to is this key lookup right here. It looks fairly innocent at first, but if I hover over it and zoom in a little bit, this may take a little bit of artfulness to get it in the right part of the screen. There we go. And we check out here. The estimated number of executions is 1. SQL Server thought it was going to have to run this operator once. The actual number of executions, there is my number of executions. It doesn't say actual in this one. It says number of executions, is 200,499. So when SQL Server went to create the best plan to go get my data for me, it looked at those statistics. It said, I have rows that are up to just a few minutes ago. I have about 1 million rows that are up to 2 minutes ago, and they're all distributed before that. So if you're asking for stuff that's tomorrow, I don't think you're going to get much back. I'm going to create an execution plan for you that's really cheap if you're only getting a little bit back, and I'm going to run with that. And that would work really, really well if the statistics were right. Since the statistics are out of date, since more has come in since then, but we haven't tipped over the point where our statistics would change, we have a lot more than that. And things that have happened to me, I've had this issue where I have millions and millions of rows, really wide rows that are larger than that. So I get a nested loop lookup operator that's going and going and going and going over and over and over because it doesn't have updated date information. This problem can happen on any type of index, but it's most prone to happening on date time or date time 2 or date valued indexes. If we check out our sort operator here, we get even more information about what went wrong. In the warnings here at the bottom, it explains the operator used tempdb to spill data during execution with spill level 2. Spill level 2 sounds extra threatening, right? Spill level 2. Spills aren't great. This means when we went out on this mission to do this query, we allocated a certain amount of resources. We didn't have enough resources, so we had to go dump stuff in tempdb when we didn't think we would have to. That's not good to have happening on a regular basis. That's pretty expensive. So if you're running stuff like this a lot, it can create some problems. What can we do about this? Let's make double sure. Let's look at our stats and make sure that this happened with our existing stats, and it did. We can see that our updated time is the same, our rows and our rows sampled are the same. So let's insert one more row. This row is going to be again for tomorrow, and it's going to have 5 as units sold just to make it stand out. So we did our last little row there. We'll try our query again and see what happens differently. Okay, so we got our new one that we just inserted came back in our results, right? So now we have 250,000 that have been inserted, so we're good there. Let's check out our execution plan. Totally different. Because we inserted that last row, When we ran this query, when we ran the select query, SQL Server at that time saw that a lot of stuff had changed on our date time index. It went and updated statistics real fast, and it figured out, I'm going to get a bunch of rows back. So you know what? Actually, in this case, I'm getting so many rows back, it's not even worth it for me to use that non-clustered index for you. It went past a tipping point where it doesn't want to do those 200,000 lookups, and it said, you know what? A clustered index scan is actually better than that for what you want.